Hello Internet, today I want to take a look at testing this character controller that we've been building, though we're not going to be working on testing this character controller, if that makes any sense. In the last video we made I guess an injectable character controller that uses some abstraction patterns to make the controller a little bit easier to test. We're going to be looking at writing tests for that, and then in the next video we'll look at taking what we have in this current platforming character controller and moving it into that model, assuming this testing goes well. If it doesn't, we'll rethink things. But I'm pretty confident that we're gonna have a good time. So the point of tests, the reason we test things, is because manually testing things, having to hit this run button every time you make a coding change and test every feature and make sure that all of them are still working, turns out that's actually a lot of work. And as you get further and further into a project, you forget more and more about what previous things did. And so it's useful to have something that can help validate those things going forward, especially if you're working with multiple people and you have different people building different sets of features. You probably want your features to work on all of your coworkers or all of your friends or whoever you're working with. You want your features to work in their code as well. And so the way we do that is with tests. The most basic of those is unit tests, and then there's integration tests, and then end-to-end tests all the way at the top. You'll typically see it as looking like a pyramid. I don't know why I'm giving you a visual of a pyramid, but the idea is you have a lot of unit tests, and then you have a few integration tests and a few less end-to-end tests. The problem as you get further up that pyramid, as you get towards those end-to-end tests, is that things get very big and they get very brittle, because you're basing something off of not just how one component works, but how all of these components integrate together. And so the problem is components can change, they can shift, they can do different things over time, and there's just more change in a larger area. And so end-to-end tests just tend to do that, and they give you less actionable feedback. If an end-to-end test fails and you know your game is broken, that isn't actually that helpful. You have to go through the logs and figure out what broke. With a unit test, the reason we try to prioritize them is because they give you very specific feedback about what isn't working. Because they're testing specific units of work, they're testing very tiny little things, like if I press this, the character goes right. It might not even be that. It's if there is an input to go right, the character goes right. That can be a complete unit test. And so the advantage of that is, if that test doesn't work, your character isn't going to go right. You don't have to try to look at anything, try to go through logs, and there's usually a very small number of lines of code that are covered by each of those tests. And so where the problem actually exists is also fairly easy to find. So that's what we're going to be looking at today. There's a whole bunch more on testing that we could go into. I'm going to try to gloss over it, but I kind of want to introduce Unity's testing stuff, just so that you can hopefully start writing some of these for your own games and make your own software a little bit more reliable. Unity uses NUnit for testing, I'm pretty sure. This Unity testing is not something I'm very familiar with. It's not an area that I worked a lot with, but we're going to be exploring it and hopefully figure things out. Unity offers two things. They offer edit mode tests and play mode tests. We're going to be looking at edit mode tests. Play mode tests are going to give you the option to test things over time. I'm less familiar with what those would be used for. I have some ideas, but we'll get into those as we need them. For now, we have really basic C# classes that aren't even depending on anything in Unity, and so hopefully they're going to be pretty easy to test. So I've created this edit mode test folder. When you do that, it creates an assembly for you, and this one is specifically designed to only run in the editor. And I've included a world-of-zero.platform assembly in it. That platform definition is right here. So this is something that I created, just going into the create assembly definition and defining it. When you put it inside of the scripts thing, everything below it gets included. And so this gives you a way to actually specify component parts, and then you just need to tell your test to actually include that, because it won't by default. I don't really know why that is. It's Unity testing is a little bit weird, but that's not the point of this video. Anyway, we've done that, so all we need to do now is just right-click, create, and not that. We need a testing test script. And so we are going to do a injectable character controller tests. I tend to find that adding tests somewhere into your classes and into your function names is useful, just because it makes it very explicit what the thing is, but it's not usually required. There's no actual reason you need to do that. I just do it because it's nice. We need to include our namespace. I have modified this slightly to include a namespace. Things don't work quite as you expect if you don't include a namespace, so I would recommend using namespaces if you're doing this. And so we want to test individual things. So the first thing that I'm going to do is, I guess, test, let's see. Really what we want to do is validate this action. That is the core part of what is actually happening in our game object. This and generally testing mono behaviors is more difficult because you can't just instantiate a mono behavior in Unity. There's extra stuff you need to do that, and so we'll look at testing this specific block of code at a different time. Really what we want to focus on is this class, the movement action class. And so that takes two components right now. We're probably going to add a third, and moves the position. And so what we want to do is give it an explicit controller input and see if the position moves after we act on that input. And so we can drop this one. That test is more for other things. And this is just going to be our basic test. So we're just going to do example test passes, and we're going to make it fail. So a lot of these are done using assertions. So assert r equal, and we want to say foo is equal to bar, just using some basic programming things. This is asserting that one side of the string is equal to the other. In this case, the expected is on the left-hand side, and the result, whatever comes out of our class, is going to be on the right. And so if we save this, we've now created our first test. And so we can now go into this and explore our test. So we have, under tests, we have this single example test passes, and we should be able to run it. How we do that? Run all. There we go. And so you can see this test failed. We get a nice red X there. And now we have expected foo, but was bar. And it's going to show us exactly what happened, how long the strings are, where they differ, so what index the difference starts at, and where that difference was. So we now have an exact point where our test failed. Line 17 of that test, right here. And so this kind of gives us some nice handy feedback about what is going on, what's broken, what doesn't work, and how we can do better. So now that we have that, that isn't actually very useful. What we want is a way to mock this. And so I'm going to test everything by mocking out everything around it. So we want to leave the tested part untouched. We're not going to modify this movement action at all, but we are going to modify this player position and this movement input state, because this is expecting an input from Unity's input system, and we can't control that from our test, but we can modify a derivative of it, and that should do the same thing. So what we want to do is create a new class that does that. There's probably easier ways to do this. I am not super familiar with NUnit, and so some of these are probably have better ways to do it, but we're mostly looking at just writing these tests and getting this test coverage, and then we can improve over time. So we're going to create a public class. What did we want? What even was I deriving from? The movement input. So movement mock is what we'll call this. And so this is going to provide mock inputs that we specify back to this thing. And it has a horizontal and a vertical input. So public override float horizontal. And that's just going to return a horizontal value that we're going to provide, not like that. There we go. And public override float vertical is going to do the exact same thing for the vertical input. And so we need two other things, private float horizontal and private float vertical. And then I'm just going to provide setters for those. So public movement mock of float horizontal equals 0. I think we're just going to provide default values there. That way, if you don't provide a value at all, the movement mock will be zeroed out. So if you just need a movement mock, you can just say new movement mock and not need to specify anything. That hopefully gives it a little bit nicer feel. And then vertical, we need to give it a type. This is not one of those kind of languages. There we go. And then this dot horizontal equals the horizontal, and this dot vertical equals the vertical. So it gets a little bit long here, and that's unfortunately kind of expected, but we only need to do this once per class. So this can be reused throughout every test class that needs to call this. So that will bring things down a little bit. But at this point, we have something where we can provide a movement without having to do anything else. We can replace the Unity's input system using that movement mock. The other thing we need is a player position state provider. And this one is also going to be fairly easy because we can just get rid of the transform. So we're going to mock that out as well. Again, I'm pretty sure there's going to be some way to improve doing these mocks that makes it so you don't need to write all of this out all the time. I don't know it at this point, and hopefully we'll figure it out. If you know a better way, let me know, because that would be super handy. We're going to do a player position mock like that. And so we want to mock a position. So private float position, not like that, position. And we're going to say public player position mock like this is a vector 3 of the position. That was supposed to be a vector 3 up there. There we go. And we want to do this dot position equals the position. And I want to do a public override of our position. So this is going to accept some sort of position in it. We want to override that and do position like that, and do get return position. We could simplify this actually, but we're already committed. So position equals value like that. So super basic stuff. Like this is not intended to be super nice so much as just to provide a way to get rid of this. There's no argument for given that course. Oh, because we can't create the transform for that. So we need to do, how do you do this? Is it like base? No. So we're just going to set the default to null. So the transform, we're just going to override and say it doesn't exist. It's null. Because we're overriding what's reading it, it should be fine and we shouldn't run into any issues. That's probably not the best way to do that, but that's what we're going to do. Most of the goal here is not to make this super pretty. It's to make it pretty enough that tests are readable and give us valuable input. But this doesn't need to be designed necessarily as nicely as everything else. It's nice if it is, but in my opinion, a lot of this other code takes priority as far as that. But for the most part, if your tests are readable, that is probably the best state you can get your code to. Because if your tests are readable, then everything else is going to be readable as well. Because your tests are going to be calling all of your other functions and manipulating them more than anything else. I don't know if that's a helpful way to put that. But those are our 2 mocks. We have one other thing that I want to do. Because this isn't quite enough to get this to work, we have a time input here. So I want to pull that time out and actually have a mock for time. Because if we can mock the time, then we have less problems. Because right now, if we're testing, I don't know what delta time is. And so we want to make that like some sort of constant, like 1, for example, so that isn't a part of this formula. So that I can just take the mocked movement and the speed that I give this movement action and get an expected result out. That is sort of the goal. We can't do that so long as this exists. So that is going to be the next thing we're going to create, which is just going to do this. It's actually going to be even shorter because all we need here is a time state provider that is going to do delta time and return the time.delta time. Like that. And that's it. So this needs to be added here. So we need the time state provider. There we go. And that'll just be time. And then we need to modify these to do time and capitalize the D for delta time. And so now we're using that delta time. This is slowly getting slower and slower as we do this, just because we're constantly having to do all these dictionary lookups inside of every update. We can fix that. That just hasn't been a priority right now. There's other things that we're working on. So time state provider, that's there. So that should now be available and accessible here. Just to make sure everything is working, we can come back to this point. The only downside with writing tests is if your tests don't compile, your game won't run. And that is a little bit annoying because I would kind of like them to be separate just so you could keep running, but you can see everything still works. We're just pulling the time from a different place. And so we just need to use another one of those mocks. Where did we have it? Movement mock like this. This is going to be the shortest one because I'm just going to explicitly say it's equal to 1. So delta time return 1.0f done. And so that is our time mock. And it's going to extend the time state provider like that. And there we go. That is that entire mock done. So we have all 3 of those. Now we just need to test this. So we have our movement action. It can inject a speed, and then it can move vertically and horizontally. So we're going to test those 3 states. So is there a way to do, does this do facts? I forget. That's an XUnit thing. So no. Sometimes there's a way to do a collection of tests that test additional inputs and expected outputs in a single test. So you can provide multiple inputs and outputs in the same thing. I am not aware of how to do that in XUnit or NUnit. So we are going to ignore that for now. That's going to mean this is going to be a little bit longer, and we're just going to be writing additional functions for that. But keep in mind that can probably be shortened down, and I just don't know how yet. So just want to call that out. For this, we are going to do speed affects horizontal movement. So we're going to test that speed value that we're passing in affects the horizontal movement of our character. So in order to do that, we need to create this dictionary. So we need to set that up. In order to do that, we just need to do a var states equals new dictionary of type and I state provider, like that. And now we just need to provide our states. So type of time state provider. And we have another one for the type of the movement input state provider. And another one for the type of our, what was it? Player position state provider. There we go. And so we just need to provide our mocks in these cases. And we're going to have specific values plugged into those. So we're going to have our player mock, our movement mock, and our time mock. The first time I write this, and probably a few other times, it's going to look really gross. That is expected at first, just because that's like trying to keep things procedural and linear, rather than use a lot of abstraction right off the bat. Because if we do that, it becomes less readable. And the readability of test is a really important thing because it kind of defines, less so in unit tests, but more as you get higher and higher in the stack, it sort of defines the things that your system provides. And so it's kind of a way of saying, this is how this feature is expected to work. And so you can have business people or game designers or whoever. I know less about how this is applied inside of game design and more about in the software industry. But ideally, you would have inputs from product managers or something like that that is going to be able to say, when this happens, this should happen, and this should happen, and this should happen. You can write your test based off of that input. And so your test can be the exact same thing and say, when this happens, this should have happened, and this is what I expected. And then this should happen, and this is what I expected. You can do that exact same thing, and it kind of helps capture that business rule. You get that same benefit. And the nice thing is it kind of helps create that synergy between what the business is wanting to do or what the game is wanting to do and what your code is wanting to do. It helps connect them. That's, I guess, all I need to say there. Anyway, for the time mock, we don't need to do anything. So I'm going to do time mock here. Because it's always just going to be 1, we don't need to keep that as a value. So that can always be that. For this, we're going to need a few other things. So I'm just going to leave that as it is for now. And it's going to be really angry at me. The next thing we need is our action, our movement action. And so we're going to do movement action of something, let's say 5. Var action equals this. And so what I'm going to do is say action.act. And we're going to give it our states. And then I'm going to say assert.r equal. And I'm going to assert that my current movement mock, for example, or position mock, that's what this should be. The position mock is now equal to some expected value because it's going to be at one state, and then we're going to move a set amount of units, 5 in this case. So we're expecting to move 5 to the right or to the left. Ideally, you want to test one thing per unit test. You can, and I see this a lot where you have like, let's do this, and then let's do this, and then let's do this, and then let's do this. So what I could do is test moving right, and then I could test moving up, and then I could test moving left, and then I could test moving down. The downside is your tests aren't going to be able to tell you what isn't working and what is working if you do that. Because the thing that fails is the speed affects horizontal movement. If we've tested all of them, even if we've tested right and left, if only right isn't working, then I do not know which of those two is actually functioning, which one isn't, because my test didn't tell me. And so trying to be as explicit as possible can help there. All right, so movement action is there. We need to do a new so that that actually knows what I'm talking about. And then we just need to create our mocks. So var movement mock equals new movement mock. And we just want to say horizontal equals 1. So that should move us right 1. I'm using named parameters here. Why doesn't it like that? Okay, I'm using named parameters wrong. There we go. So named parameters use a colon and then the value, and it's a C# thing. So if I did vertical 0, for example, I've done the same thing. The only difference is, and this only works with named or parameters with default values or optional parameters. But if I want, I can just specify the vertical. And so I don't have to, if I am going to specify just a vertical and I want to do that, I can use named parameters. And it makes it a little bit more explicit when you're doing something like this. Whether that's useful for 2 parameters, I'm not sure, but we're going to do it. So we're going to move right because we're giving a 1 to our horizontal movement, and then we need a position mock. So a new position mock, and we need to give it a default position. So I'm just going to do, we don't even need a new vector3. We just need vector3.0. So we're going to start at the origin, and I expect this to be equal to, the expected value is a new vector3 of 5, 0, 0. So we're expecting to move 5 to the right. And the output is going to be equal to the position mock.position. So that is the state that should have been updated if our test worked. That is where all of this should happen. And so this is what our test looks like. We're creating these 2 mocks. We're creating the set of states that tracks all of them. And then we are assigning them into this state. So we should be able to do something like this and run our test and see that it passes. And so now we know that that goes that way, except we don't really know. We just know that the test passed. So there's a problem here, and it's really easy. You don't really know if your test works until it fails, if that makes sense. Because our test passed, it could all be good, or our test could be wrong, and we could think it's right. So if I expect it to be, say, 6, we can run this now, and we should see this fail. And so we'll see, hopefully, or not. Oh, I'm just scrolled way off to the side. Here you go. So we can actually see our test is telling us we expected to get 6 and then 0, 0, but we actually got 5, 0, 0. And so it's actually telling us the value of the vector3 that we got back that wasn't correct, and also all that other additional information about what failed. But this is actually giving us values about what worked and what wasn't right, and also what the actual results were. And so we can reuse this to test vertical speed. So we can test that as well. And also I should mention, the only thing we've tested so far is that a speed of 5 is applied all the time. Because we haven't tested this multiple different times, we don't know what we don't know. So there can be some coverage there that could be useful. So we're going to do the same thing, but we're going to move up. So I'm going to set this to vertical of 1. And we expect it to be 0, 5, 0. And so that should handle vertical and horizontal movement. We have 2 tests, and we can run them, and they both pass. So the other thing we want to do, I guess, just to double check, is work with that speed. We'll probably get into that actually when I start figuring out how to do facts. Facts are XUnit's way of collecting a whole series of things, and so we could say there is a movement speed, and we would just expect that to be the output here. Actually, I'm gonna go look that up, figure that out right now, and we can just do that for both of these and get them done, and then we can also worry about handling some of the other states that can happen here. But that should be it, because we've effectively tested horizontal and vertical movement, and that we're reading the actual values from this. Because if we were reading incorrect movement, we would be getting different values, or if we were not setting the position, we'd be getting different things. The time, we've kind of implicitly tested that we could probably do a better job there by modifying that and doing things, because maybe we're just using 1 or not multiplying by it at all. Because we've effectively removed it from the equation, if I delete this time, it's not going to work. But to kind of emphasize some of the usefulness of this, if I delete this speed for whatever reason, if that goes away, these functions don't look much different. And there isn't, if you're just glancing through this, you're probably not going to even really notice. And especially, I think, oh, we are using 5 there, but you might not even notice that anything had changed if we were to run this. I don't even have the game object in this scene anymore, so that might be a problem. But the idea, if I run this, I don't even need to run my game. I can see that it's wrong because I only got a fifth of what I expected in our movement. And so we can rely on our tests to kind of give us those early indications and kind of help us get that information back. Another useful thing with this is you can integrate this into a CI environment. CI is continuous integration. So the idea there is if you check code into a source repository, say GitHub or something like that, you can run these tests every time somebody tries to check code into your repository. So every time somebody tries to review a change or something like that, you can run these before anybody else sees it. And the advantage of that is, 1, you don't accept breaking changes into your code, and 2, you are able to actually validate things before you do, say, a build for Steam or somewhere you're launching your game. It gives you that extra confidence that, well, yes, this actually is going to work. In this case, we're testing a very small chunk of what we actually have written, but we're getting there. Anyway, I'm going to go figure this out, and then I'll be back. The way to do multiple things in NUnit is with theories. So the way this works, instead of doing tests, you would label them as a theory. And so that is an extension on a test, I believe. Maybe? Not super sure. But what we can do is now specify data points for this. So you can specify data points in 2 ways. You can do it like this, or you can actually provide class level data points that will provide that to everything in here. Now, this isn't going to do anything because we don't actually have a value here. So let's give it a movement amount. And this is going to be the amount that we're going to move in this function. So movement amount of that, and we're going to say 5. Let's do 1 first. So our data point is going to say 1. Does it not like that? Okay. Why doesn't it like that? 1 sec. I thought I knew what I was doing, but the thing that we need to use is data points. And I have been using it wrong. And it seems like there's some finickiness with NUnit. I'm not sure what my thoughts are on that whole thing yet, but we'll ignore that. So the way this is going to work is we need to describe some sort of IEnumerable type that has the data points attribute attached to it. We could also use data point and specify multiple of them, but this is going to provide a data point set of things to every test class underneath that class. So if we wanted to provide additional data points, we need to split these up. Since the results are pretty much the same, that isn't a big deal, but it could have been. Private IEnumerable, I guess. And this is just going to floats. There we go. That seems more useful. And this is going to be our movement equals new list of floats like that. And now we just need to provide things. I suppose yeah, this will be fine. It's just annoying. Anyway, we'll do this. And so the values that I want to provide, the movement amount is going to be 0, 1, and 5, I think. And so we'll test if the movement amount is, if the speed is 0, effectively, we don't want you to move at all. You should just be stuck. If the speed is 1, you should move 1 unit, and if it's 5, you should move 5. And so we just need to change these two 5s out for the movement amount, because that's what we're doing. We're moving over 1 second, we should move 5 units. That is what this is saying, so hopefully that's what we get. And we want to do the same thing down here. So theory of float movement amount. And this should be our movement amount along with this one. All right. And so now we should have 6 tests instead of 2. And it should test a little bit more than it was testing previously. So I don't know how Unity is going to represent this, but we're going to see. Cool. So it actually interprets that correctly and shows you there is a horizontal movement speed test for 0, for 1, and for 5. And it will show you all of those. And so if we run these, we'll see all 6 pass. But if I were to go in here and mess up my test or something and change this to, or let's assume the test is correct. The test can be correct. Let's go and look at this injectable character controller. Let's drop the speed to, and let's put in a hard-coded 5, for example. So with the previous test, this would have still passed because we had hard-coded 5, which matched what we expected in the test. These tests, 2 of them should fail now. So if we run this again, we get 2 failures for 0 and 1. And it's going to say we got 0, 0, 0, or we expected 0, 0, 0, and we got 0, 5, 0. So we're 5 above where we wanted to be. So something isn't quite going as expected. So we need to go here and change our speed back. So I guess that's that for inputs. The only other thing that I think we should test is going to be tested in a separate place. We can actually probably put it in this test as well. But what it's going to do, it's probably easier to just copy this. We want to test no input. So if the player does nothing, what happens? So in this case, no player input, no movement, I guess. It seems like adding passes is like Unity's thing. I don't know what I think about that, but there's no inputs here. We don't need those. So we can just put a test. I'm doing this mostly because I'm curious what will happen. Our defaults are 0 for that, and the player position mock should be 0 as well. And so we should just be able to expect this to be equal to the 0 vector. Movement amount is going to be equal to, it has to be some non-zero value. It doesn't really matter what it is as long as it's something that isn't 0. And so we should see this become something. It should pass and get us a 0 value. I'm curious how it works with those data points. It seems fine. And so that ends up passing because we didn't move like we had anticipated. There's other assertions that you can do, like is greater than or is less than or not equal to, that you can use them as makes sense. But that is pretty much it for now. We'll probably continue this and start doing more and more of this, but hopefully this gives you a little bit of an idea about what testing is good for and why it might be useful, and also how you could start writing your own test for your own project. Like I had mentioned earlier, using mono behaviors, it can be a little bit hard in tests because Unity doesn't quite let you instantiate them like I just did there. Because of the way we have everything laid out, testing is fairly straightforward. We know what we need to create and we know how to create it because they're just basic classes. Mono behaviors have all of their own stuff and they have their own life cycle, and the same thing for like game objects and things like that. So some of the more complicated Unity objects are going to be a lot more difficult to put tests around. And so that'll be something we'll look at later. But I just kind of wanted to give it a general idea about this and hopefully take a closer look. So that is all for now, and we will take more of a peek at this later. There is a mocking framework for NUnit. I'm going to look into that on the side. We'll probably come back and figure out a way to make all of those mocks that we made a little bit nicer, because right now they're a little bit gross. But that will happen at a later time. So anyway, that's it for this video. So I guess until next time, see you, Internet.